Hello everyone and welcome to the EfficientIP webinar titled Application Access Control, Leveraging a Low List to Make DNS Your First Line of Defense, presented by Ed Daniel. I am your host, Pascal Tangaprigasam, EfficientIP Senior Technical Marketing Specialist, and we realize your time is very valuable, so thank you for joining us. Before we begin, I'd like to go over some housekeeping items. If you're joining us live, you will receive an email within 24 hours with a link to the replay recording of this session. We would hope that you would share this link with your peers so they can view this webcast on demand at their convenience. Also attached to this same email will be a link to download a copy of the slide from today. Taking a look at the agenda today, we are going to see why DNS security matters and zero trust foundations, DNS security layer between user and apps, the demo, application access control per client, and we will finish with the illustrated use cases and takeaways. Then we will be hosting a question and answer session at the end of the live broadcast, and myself will be available at this time for any more technical question on our solution. To ask a question, simply enter it into the question pane in your webinar console, and we will do our best to answer as many questions as possible. Now, I am very pleased to introduce my colleague, Ed Daniel, Customer Solutions Architect EMEA for EfficientIP, based in the UK. Ed has over 20 years of experience in information technology, complemented by a specialization in cybersecurity, and is active in both security and open source communities. So, Ed, thank you so much for joining us today.
Thank you, Pascal. So let's get to the very first thing, why DNS security matters. It's quite disturbing to see. We don't even really need to get into the technical. Try and throw that at you. Here's the stats that from our surveys, and also surveys from Cisco and IDC. IDC in 2021, dare I say. So it's not really out of date stats. And the first one, 87% of organizations are suffering DNS attacks. 76% have suffered downtime. It's now up to $1 million, the cost of a DNS attack. 1 in 4 organizations are having these issues. This is a very disconcerting thing to have to report, really. So the 3 reasons why DNS is on the top of the cyber criminals list. 1, it's mission critical, so it's everywhere. It's very easy to exploit. And it's not efficiently protected, is the challenge that we have. So it's been quite interesting as more attention has been brought to how can we better do security. The industry is evolving very, very quickly, and probably the most important trend coming in now that's starting to be adopted quite widely, or certainly being explored, is zero trust foundations. So basically the concept of zero trust and how to implement zero trust. And I've got to say, I'm delighted at EfficientIP. I've been here 4 years now, and already Guardian was one of the first innovations that EfficientIP brought to market. A couple of years back was GSLB, and today I'm very proud to tell you about what we can do with DNS and how this complements zero trust solutions and ideas and architectures and designs. So what we already know about zero trust, of course, it's granular visibility and control is what they're trying to get to. The concept of micro-segmentation, being able to, almost in the same way with marketing, they've got you targeted down to you. They know everything about you. The marketing is going straight to you. You are the person that will most wish to receive that particular marketing. That kind of accuracy in the marketing world is what we're trying to search for in the security world as well. We want to be able to give people exactly just good enough security policies, not to have them accessing to everything. The need to have this in real time is essential. You can't have things that you switch on and forget to switch off again. They've got to automatically switch on and off. Real-time analytics is allowing you to do that when you think about automation orchestration. So zero trust is a very compelling concept and idea in being able to better secure your networks. So we'd actually like to just talk a bit about how we can give you another very significant arrow in your zero trust approach making it basically your first line of app access control. So why are we saying this? So DNS has granular visibility over 100% of your IP traffic. Now you're thinking I'm reading from the slide, but I'm not. I am seriously telling you, 100% visibility. All the stuff going on with your apps relies on DNS. If you're not watching it, how do you know what's going on? But it tells you so much about what is going on. So this, as you can imagine, it is very interesting in terms of the security narrative when you take that view of DNS. But one of the challenges is that most technologies thus far haven't really been able to exploit what's going on in the DNS. The DNS data, it's offering precious contextual information for security and application access control. So you're getting a lot of information that you could be tapping into. So DNS sees traffic intent at the earliest point in the IP traffic flow. Yeah, and what we mean by that is that, after your device has got its IP on your network, the next thing it needs and will use is DNS. It hasn't even got out your network. It's already needing to use DNS. So DNS analytics can prevent and detect threats in real time. What you're going to have is a very interesting behavioral threat detection scenario. So already DNS, this is what we say, well, by having it as your first line of defense, you're already being able to detect potential issues and also automatically mitigate those. And then, of course, based on your own threat intelligence assets, you're able to use these to also influence the way that DNS requests are made inside your organization. So what we'd like to really sort of promote now here is, if you're integrating DNS with a security ecosystem, it's going to automate and orchestrate responses. So we're improving enterprise-wide detection, preventing the spread of attacks, accelerating remediation, and we're delivering the DDI-enriched information that currently isn't being exposed in your organization. So very much what we're looking at is how we are now integrating with a variety of technologies and providing them with actionable data. So the SIEM is getting the information it needs. The analytics are sharing information on the load, the capacity, of course, but more so, they're also letting you know which populations of users are having which particular behaviors. And then you're then be able to then apply behaviors and basically enforce security policies with this kind of design and architecture. So for us, the solid server DNS for zero trust takeaways, we're going to see all intent, internet traffic intent. Visibility is going to be down to your individual client or device making that request. So you're getting the granular visibility and control right now before you even think about trying to deploy agents or have other solutions that are scanning your network. The DNS is going to give you the clues at the very first off. Another aspect, of course, is going back to the real-time analytics. With user behavior analysis, you're then able to then take into that account for DNS filtering for app access control. And then again, the automation. If you can't automate and orchestrate, you're never going to scale. Being able to do this at the DNS is you've automatically scaled, yeah, because you've got a DNS architecture that's providing that scalability for you. But then what you're doing is you're juicing that with this ability to use dynamic policy enforcement that relates to a zero trust architecture that you have either bought or are building. Right. I hope I haven't killed myself and gone ahead of my slides here. So the traditional solutions are not sufficient to secure application access at client level. What we're finding are the issues is that when you're trying to use authentication, that's not necessarily going to work for different kind of segments, even ones that are changing often. And how do you keep your IAM policies up with dynamic environments? The concept of blacklisting or voice deny listing. Again, it's that challenge of known knowns versus unknown unknowns. Really, it's the best way is to go with an allow only list kind of a design, but again, it's still not sufficient. People get irritated when they can't get to particular things or services that they expect to consume, either professionally or personally. The concept again of having an all or nothing policy, because of if you're doing stuff at the perimeter at the firewall, it's probably an aggregation of all your different users in your ecosystem. So you can't put a firewall necessarily in front of every user. There is generally also the challenge of what would you do if I'm trying to manage that or scale that? So again, it's things that people have been looking at. There's also been sort of, some sexy routing, doing very clever routing. We're seeing that this is evolving in our space with, shall we say, network function virtualization. It's still very fresh. It's still very complex. It's still very expensive. And not everyone's taking that route. And there isn't really anything that is able to manage these challenges. So one of the things that we've found with the ability to do client filtering is that by the policies being applied to clients, not only to the destination domains, so you're bringing both together as part of your policy orchestration, you improve the filtering granularity down to the individual client. Remember what I was saying about the Google Ads thing. This is something that has not been possible before with DNS. It's really key to share. So again, delighted to be sharing this with you today. It's a new technique. It's new engineering possibilities with DNS that were not possible before. You may have tried to hack this together if you're one of the more Uber engineers on the webinar today. It's not as simple as you think, and one of the beauties of this is its ability to inject and pull out items within this collection of filters. So you've got a new security barrier to reduce exposure and risk, as well as also looking at new use cases around DNS and the control of the user. See, it's not just about the bad stuff of DNS, of course, we're concerned, but it's also about managing how DNS is being consumed. If you can actually segment, there are things you can look at, like IoT security suddenly becomes reinforced. It can be isolated in an environment. Cloud access control, SaaS apps, guest networks, employee networks. All these things can start to be segmented and monitored and analyzed with DNS. So just going to sort of flip from one bit to the other now. I do actually think I also introduce it as well in the next slide. I better do that first, forgive me. What this demo shows, essentially, the idea here is we want to show lots of clients making lots of requests in a potential ecosystem, and they're going to try and access various things. As you can see on the slide here, these are the various silos or classifications of web access or HTTPS access, whatever, relying on DNS. The point is, across all of these, we're going to show you that from basically what you'd normally see in an environment in terms of the rules, as to what we kind of have with this sort of nirvana of everyone being able to access only what they need to access. Yeah. So that's the sort of the end goal as you see it there, the frame there. But what we're going to very sort of first kick off and do, start some clients that have been making the DNS requests. And then what this grid will update shortly to show you essentially is that in an environment with no controls, I'm not saying everyone's got this, some people have got some controls, that's the next step, by the way, but in an environment, what you're going to see is normally DNS access. So our wee little clients, once they are being correctly routed in through the fire hose, was essentially this is aggregating events coming from the DNS service, and then we have a kind of a loopback feed there. So there we go. So it's now updated, and what we see is that everyone has currently got access to everything. So we've got a sort of an example there of some sort of standard sort of web shopping sites, external email services, your internal apps, the SaaS apps, the IoT services, and out to the net. So not ideal. I mean, that's obviously no, I'm not expecting that many of you have got that environment. And if you have, then we have to have a conversation very fast. But what we do normally see is the following. So there'll be in the environment the ability to probably have some kind of allow and deny listing across the entire security ecosystem, what I call the security fabric. So of course in so defense in layers and all that, but essentially the security fabric, I don't think layers don't work anymore. It's more of a 3D, maybe 4D kind of thing. Security is quite challenging, but the point is that normally you're going to at least be able to have some IPS or IDS kind of filters. You'll probably have some firewall rules that have got some DNS matching. You've probably got some sexy stuff from another security vendor that does something, but it's normally quite sort of broad brush. And even the cloud-based services where you've got policies, the challenge you have there is the traffic leaves your perimeter. So if the cloud service is down, everything's open again. But more so, it's almost like behind a net. They can't necessarily identify the clients and apply the policies to the client immediately, sort of after the fact. But that's what you'll tend to see. So the user population, the clients as we call it, making DNS requests in your environment. We don't know which clients they are, but they were able to essentially just access a few things. Now, of course, in the second example, what we're sort of trying to suggest now, well, what if we could split those clients out into two sets? I mean, and again, we're going to move. This is just sort of showing a step-based approach, just so it makes it easier to follow. But what you'll see is that we've created two sets now of clients, employees and unknown. And bless it, it's going to update in a moment. And when it does, you'll see that certain users will have certain access, and the unknown users, of course, should have none. And this is sort of getting towards what we want to do, but we're doing this now. This is key at the DNS layer. Okay, when the client is making the cache recursion, it's not able to go any further or have to deal with any other security armor of the organization, as you see there. And it's been restricted now down to employees are now only allowed to access intranet apps, or they can go out to the web and search, but everything else has been caged off. So it's a bit tough, isn't it? I mean, I've worked in places where it's like that, but it's a modern world. Things will improve. So what we probably want to do is obviously split these groups out into something a bit more granular. Now, here in that node, remember we were talking earlier about the granular visibility and control, and here I'm showing you control and the ability to do that in real time with a particular DNS ecosystem, an ecosystem of clients making DNS requests. So here we see we have an IoT segment, a NetOps segment, an employee segment, and an unknown again. And what you'll see there is NetOps has actually got the SaaS apps and intranet access, but IoT's been now segmented out. They've just got those two domains they're able to access and work with. It's what we've been looking for with IoT. How are we going to protect IoT when those guys are building stuff that is actually becoming technical debt? It's never being updated and what have you. How would you secure the evolving landscape of IoT security? Well, DNS. So, but of course, in this example here that you're seeing, one of the things that we still haven't yet got to, of course, is something a bit more, sociable, shall we say. So we'd probably want to make it a bit more granular. And this is a pretty good example of what would be a common implementation that we would do. So here you'll see you've got a guest network that, well, of course, it will update shortly. Forgive the demo, bless it. But what you'll see is the guest network, they'll be able to access what they should. So we'll let them go to Google, we'll let them do their web mail, and we'll let them use their SaaS apps, but nothing else. You'll see unknown is still not touching anything. IoT is still behaving itself. Employees have actually been given an upgrade. They can now get to their SaaS apps, mainly because everyone's gone to Office 365 and Zoho CRM, and you need the employees to access that stuff. But you're keeping them off their sort of the shopping and stuff. They can't shop at work. I don't know, probably an Amazon thing. Anyhow, as you'll see, using the DNS before anything else for traffic across your environment, you can now use this as an added layer. So it's quite a thing. So thank you very much for watching that. I hope I've been able to communicate it clearly. But before we leave, just sort of consider you have a DNS policy, okay, around this matrix here. So you can fit this to whatever you need in your organization. And what it will probably do is give you the scenario of where you're going to see stuff you wouldn't expect, because when you're starting to gate stuff off, the events you see are very interesting. And you often find, well, why is that device needing to make those requests? So thank you for watching that. We recorded in case of the demo gods. As you know, it's never fun. Right. So, EfficientIP DNS Guardian differentiates controls access to internet categories, websites, any clients, so endpoints, machine to machine, IoT, internal, external applications, and of course, cloud between your intra-cloud and intra-DC. So it's quite an extensive behavior that often people have not really bothered to tackle till now. So you can now see that we've got some interesting approaches. So obviously the first real use case is just dealing with who should have access to what apps. And if you've got apps that have got sensitive data in them, this is again the benefit only the right clients are able to access, and you can do that. You can even segmenting via clients coming in over VPN. You'd be able to say only certain clients would be able to access certain corporate apps. So it's a bit like, if you're not on the list, you're not coming in. But that's what you want. But you don't want to have to manage that. You want that. Yes, everyone needs that, but you don't want the scale of managing it. Being able to do this at the DNS layer solves a lot of problems. So the other one is that I was kind of, if I wasn't alluding to it, I probably wasn't doing my job properly. But the IoT one, I just love. I mean, I've been following the IoT space for some time. I was delighted when we started to see IoT manufacturers collaborate on, shall we say, IoT code repositories that were open source, because then there was actually a consolidated sort of discussion about security. But it's still a big issue. So what we'd like to see, of course, is that when these objects are being detected or they're being deployed, there's already policies in place, so you don't need to have such a stringent control of the assets, or you can take advantage of certain asset technology, knowing even if it has weaker security, it's not going to be compromised because you've isolated it further, not just with the firewalling, but also what it's able to do inside your organization, which is kind of interesting if you think about the nasty stuff. It does happen. For a while, I think it was Cisco was having a real problem with counterfeit routers. So if you can get counterfeit routers, I mean, it's only one step beyond. You're going to have weaponized routers or weaponized technology that you've bought and you didn't know about it. It's not your fault. But if you haven't got something to protect you, it could be nasty. So zero trust strategy using efficient IP DNS security. So again, differentiate and control. This ability to obviously work with categorization. There's not just the sense of before when we're talking about, say, split horizons, but something that is more granular. It's not them and us. It's much more informative. The automation orchestration is essential to this, and the ability to be able to manage this stuff at an API level as well as just a solution to do it is key. The visibility is just such a boon because you're removing false positives because of the segmentation and so on. When you are having security events, they're much more targeted. I mean, yes, we can already do stuff with Guardian where we can identify the naughty IP within a set of behaviors that we're looking for. But it's very interesting when we know more about that IP is actually part of a particular category or group, and that matches how the business is designed. And of course, the real-time analytics, so it's always reassuring to check the dashboards and know things are working and everything's in green, per se. So we should also probably highlight what the analysts are saying. Both Gartner and IDC are agreeing with us, I think is the short version. It's reassuring to know that we're not being mad trying to promote something that isn't necessary or is some extra work for no real value add. These are respectful organizations that position their thinking as their reputation. So I don't think I need to hammer that one much further home. So EfficientIP's philosophy around DNS has always been one to be holistic. So at the very beginning, strengthening the security foundation means out of the box when we're doing DNS designs at EfficientIP, we're looking to ensure that we're using best practices in terms of how you're deploying authoritative servers, that you're separating the authoritative layer from cache and recursion, all these kind of things. So already, just your initial DNS design is important, and when we facilitate that through the way we design our solutions. Then there's the other aspect of obviously being ready for the benefit of cloud services, being able to orchestrate those. Again, as a best practice, we say for the benefits of using a global Anycast network that is at a very competitive price. Why would you fight against that? What we do though is kind of do we get you out of cloud vendor lock-in, and we also mitigate you against cloud outage. We have an authoritative DNS design that will do that for you, so you can mix providers in the design. You can mix an on-prem or a DC appliance in the name server design. So again, that's that flexibility there when you're for that particular aspect of DNS. There's the other, of course, the challenges that one sees around, how DNS is being used, as we've been talking about today. And I was saying earlier, the concept of being able to have a DNS firewall, really sort of first step in some of the clever stuff that we do. And then, yes, if you want to then maybe have the ability to use other technologies such as Cisco Umbrella, that's also possible as well to integrate with that and have that done. We were the first solution to actually integrate with Cisco Umbrella. And then the DNS availability and protecting your data, DNS Guardian is really a unique proposition in the marketplace. I have to say, we do things like with DNS quarantine. I've mentioned in videos before. So, and again, that plays back to the IoT thing that where you saw earlier. Not only were we segmenting stuff, but if an IP is misbehaving, we can quarantine it, so it's able to do some of its DNS behavior, but not the DNS behavior that could be malicious. Superb feature, and again, all of those automated capabilities, and of course. It's a horrible world out there. Sometimes somebody will set the entire internet on you. It's called a volumetric attack. It's not very nice. Reflection attacks being obviously pretty nasty. DNS is a culprit of that. We often talk about DNS as being a threat vector for as well as also being something that's attacked. So you get being used for an attack. It's not particularly pleasant. But the key here is that there's not really much you can do about it except soak it up. So our telecommunications customers are very pleased that we have, the fastest performing DNS server that can soak up 17 million queries per second on a single appliance, and we normally provide a few of those in a scaled architecture to help our service provider customers with that kind of serious issue. Normally, an enterprise isn't seeing that issue because their exposure would be probably just at the public level, and normally there we're saying take advantage of cloud service providers or our advanced name server design that uses a multi-provider design. Thank you. So better just talk a bit about EfficientIP. So we'd like to call ourselves a network automation security company focused around DNS, DHCP, and IP address management as our core understanding and expertise. We're in 110 countries. We specialize really in app and infrastructure lifecycle automation, and now we're intelligent app traffic steering, which I mentioned earlier, the GSLB, and this adaptive DNS security. We try to be very much part of the ecosystem, so we believe in open standards and open ecosystem integration. It's very much part of our core values. And our vision really is just to make your guys' lives easier, because this is not easy stuff to do, especially when it's mission critical. So simple and secure everywhere is pretty much our goal. And of course, that's helping you deliver the best user experience at all times to your users in your networks. We have operations in the USA, in EMEA, in APAC, headquarters in Philadelphia, Paris, and Singapore. Already over 1,000 customers, and thank you very much for listening. You might find some of these logos recognizable. These are customers we're very proud to share with you. Thank you. Questions?
Well, thanks, Ed. So we'll move now into the question and answer portion of the webcast. I see we already have a few questions here, but please feel free to also type into the question pane as we move along, and we will get to as many as we can. So the first question I've got for
is
you, Ed.
is the
Could
DNS
this
has to
be?
be configured or has a certification to be used?
Yeah.
Oh, okay. Um, so we there are certain cases where when customers are doing business with us, that normally they won't need to provide a certification because they're working with our partners who are certified and have that expertise. So you shouldn't need to worry about it. This is actually proprietary technology, so we don't share a lot of information publicly. It's all gated in customer portals. And in terms of would I recommend doing a certification before using this technology? Absolutely. When I joined EfficientIP, I spent, if I remember correctly, nearly the first 5 weeks doing labs and studies and stuff, and I'm continually learning. This technology has only really been aware in the business for about well, the R&D's known about it for quite a while, but guys like me, I've been playing with it for about 18 months now, and I would say it doesn't take long to learn, but it's the implication of what you're doing and the benefits. There's some really cool stuff we do with Guardian, for example, where when you spin up another Guardian instance, you can lift and shift the cache so that you don't have to have the new Guardian instance repopulating the cache, but it also requests the TTL. So there's that kind of configuration, how that's set up, knowing how that's done over a particular network. That's important to know. Anycast is pretty easy, that kind of thing. But again, I think it's always nice to do sort of labs. I would say our training is pretty solid. So if you can afford it, do the training. If you can't afford it, well, have a chat with our community guys. Maybe they'll find someone who can lend a hand if you've become a Guardian customer.
So another question. So what EfficientIP licenses or additional modules are needed to implement what is called DNS access list? So we don't call it DNS access list. So the feature is called the client query filtering.
That's easier to see the questions.
So the answer is that you need Guardian to run client query filtering, which is the
Yeah,
technical name.
well, I think we can be a bit more explicit than that. So, out of the box, our DNS role will have the ability to use RPCs. So the initial allow deny listing. These RPCs can scale out to 1 million items if they are being sort of updated regularly from a third-party provider. But that's there today. But what we were talking about, the client query filtering, that's a feature of our Guardian appliance. And our Guardian appliance is part of our solution stack, is all the same core appliance. The operating system, the network drivers, those kinds of things. But in terms of our software that's deployed there, we are able to enable it to perform a variety of roles. It could be centralized management and IPAM, it could be a DHCP server, or it could perform a variety of different DNS roles. So the Guardian appliance or the module is enabled on an authoritative DNS or a recursive DNS service. So therein, that's where you would do the configuration. Normally, it's at the recursive caching layer when it's performing that role. Hope that answers the question.
Another one. So is the solution data center based, or will there be an agent for the endpoint?
Frank, well, that's what I was actually mentioning about, this doesn't need agents. This is the really nice thing about it. You can implement this in any DNS environment already, just by putting the Guardian appliances in front of your current DNS architecture, so that everything is going through that for the cache, basically for the DNS requests. So you've got to deploy the Guardian. yes, it's being deployed as an appliance in the DNS role. It's providing part of the DNS service to you, so you can displace other services that no longer that are no longer required, because it would duplicate that. An example would be an existing DNS caching design. It would replace that. If you didn't want to replace that, but you wanted to trial it, or maybe just sort of suck it and see, you could just set up a part of the ecosystem to make requests to our caching layer that would then forward to your caching layer, kind of thing. You can, the fun about DNS is you can daisy chain, but the key is by getting everything going to one caching layer, where you have the required client query filtering deployed, gives you the control you didn't have before, which you couldn't do at the firewall level, because the packets had already got there and been natted and obfuscated in some way that you didn't necessarily know your source IP. So it is a bonus in not needing to actually deploy agents to all the devices making DNS requests, and especially if you think IoT, it's often a black box. You just plug a cable in, and away it goes. There's that kind of tech. How would you deploy agents to an environment that is essentially got no deployment surfaces? Or, well, you can hack the PCB, but it's not a good idea. So, any more questions? I think that's it for the moment. Hope that was answered okay.
Yeah, we have another one. So could this be used to filter access to SaaS applications such as Office 365?
Yeah, absolutely. As you saw earlier, when we had the domains that were available to each user population, whether they could or couldn't access them, and you saw the employees initially could only access the intranet apps. Then we changed the config of the CQF lists and said put them in the list that could access the SARS apps, and those SARS apps actually were foo.it.demo and bar.it.demo. It could quite as easily have been one of the O365 URL endpoints. It could be GoToMeeting. It could be any kind of service where you want to obviously throttle the access from the organization to it across the network fabric available. So whether it's the guest network or the lab network. So it is yeah. So absolutely.
Okay, let me see. Yeah, so not showing any other questions. So we will go ahead and wrap things up. So thank you very much, of course, to Head for giving us an overview of application access control per client by EfficientIP and delivering the demo. And finally, a big thanks to you all who attended on the line. Please, sorry, look at the email with a link to this presentation and slides within the next 24 hours. And if you have any further questions or comments, do not hesitate to reach out to us. Thank you again, everyone. And we will close with that. We will close this session. Have a great rest of the day.
Thank you.